Today we are looking at how we can find the zeros of a function and what those zeros mean. And then our second learning target is we will be finding the multiplicity of those zeros. And we'll describe what that means in terms of the graph. So let's first look at how to find the zeros of the function. So first learning target, I can find the zeros of a function. So the zeros are the points at which the function intersects the x-axis. So essentially, these zeros are the x-intercepts of the graph. And it's interesting to note that the polynomial can only have at most n real zeros. And n would be the highest degree. So if I'm looking at number 1 here, my highest degree is x to the third here. So this tells me that this graph can have at most 3 zeros. It will not have more than 3 zeros. It can have less than 3 zeros, but it cannot have more. So let's look at number 1. And I have it graphed for you already, but you could plug this into your Desmos or your graphing calculator and you would see a graph that looks roughly like this. And then to find the zeros by just looking at the graph, you would look for those x-intercepts. So I have 1, 2, 3 x-intercepts, which makes sense because it could have at most 3 zeros. And I'll take note of those. So right here, x is equal to -2. And then right here, x is equal to 0. And here, x is equal to 1. So those are my zeros. The zeros of the function. Easy as that. All right, number 2 looks like this. So if you graph it, I just plugged it into the graphing calculator and I saw the graph looks like that. And then I can see that x is at -1, at +1, and finally at 3. Those are my zeros. Okay, now what if you don't have a graphing capability and you're just given an equation? How could you find those zeros? How could you predict what this graph would look like? Well, what you would do, since we're finding zeros, we're going to set the function equal to 0, and then we're going to solve for x. So to solve for x, you have to factor it. So I'm going to first look for a GCF. What is the greatest common factor of this polynomial? And it's x. They all have the x in common. So I'm going to factor out an x first. Divide everything by x. And then I can continue to factor this. This is a trinomial where a is 1. So I'm looking for the factors of -15 that add to -2. And that would be -5 times +3. Now it's factored all the way out. So to find my x values, I'm going to set each factor equal to 0. So x is a factor, x minus 5 is a factor, and x plus 3 is a factor. So each factor equal to 0. So x equals 0, x minus 5 equals 0, and x plus 3 equals 0. And then finally, now I can solve for x, and those would be my answers. So I have x equals 0, add 5 to both sides here, I would get x equals 5, subtract 3 from both sides here, and I get x equals -3. So my zeros are 0, 5, and -3. And guess what? If you were to plug this into your calculator or into your Desmos and graph it, this function would intersect the axis at, you guessed it, 0, 5, and -3. Okay, So that's finding the zeros. Now let's talk about multiplicity and what that means. So multiplicity of a zero is the number of times that factor occurs. So when we factored it out, how many times does that particular factor seen in the problem? So let's look at number 4 and we'll see what this means a little bit more clearly. So for number 4, to factor it, we would have to first take out an x. I'm going to set it equal to 0 because I'm finding the zeros. Pull out the x. And continue to factor. So I'm looking for the factors of 9 that add to -6. That's -3 times -3. And how many times does x minus 3 occur? Twice. So I can rewrite this as x times x minus 3 squared because I have 2 of them. So what are my zeros? Well, to find the zeros, I would set each equal to 0. So from here, I would say x equals 0 and x minus 3 equals 0. So x, of course, is positive 3. But this 3 occurs twice. So the 0 of 3 has a multiplicity of 2. And that can be seen here as well. So the 0, x equals 0, has a multiplicity of 1 because it only occurs once. And x equals 3 has a multiplicity of 2 because it occurs 2 times. So what does that mean in terms of the graph? What does that multiplicity tell us about the graph of the function? Well, if the multiplicity is odd, so an odd number would be 1, 3, 5, 7, so on, like this one, multiplicity of 1, that means that at x equals 0, the graph is going to cross through that point. So if the multiplicity is odd, then the graph crosses at that 0. Now if it's even, multiplicity of 2 is an even number, then at 3 it's just going to bounce off of that value. Or you could say it's just going to touch. So let's look at example 5. So if you were to graph or to factor this, that's what we have up here. And then you would find out that x at 0 is a multiplicity of 1, and at 3 is a multiplicity of 2. So at 0, it's going to cross through, and at 3, it's just going to touch. It's not going to pass through. It's not going to change, go all the way through the axis. So let me show you what that looks like. So that's what the graph of this function looks like. So at 0, it's going through. And at 3, the even multiplicity, it just changes direction. It bounces off, goes down, touches it, comes back up. So that's what the multiplicity tells us about the graph. So let's look at another example of this, kind of practice this. Look at example 6 here. So to find my zeros, luckily this is already factored for us. So this is -7. And then this one, you would subtract the 1 here, divide by 2, so x is -1/2. And then this one, x is 4. So I have -7, -1/2, and 4. 7 occurs twice, multiplicity of 2. 1/2 is just once, multiplicity of 1. And then at 4, multiplicity of 3. So remember, if it's odd, it's going to cross through that point. If it's even, it's just going to touch it or bounce off of it. So multiplicity of 2, that is an even. So that means it's going to just touch at that point. Multiplicity of 1 is odd, so that means it's going to pass through. It's going to cross through. And then odd crosses. And if you wanted to, you could put that into your graphing technology and you would see this in action on the graph. Let's try number 7. So step 1, set it equal to 0. And then step 2, graph it. So this one I can pull out an x squared. Then I can keep going here. Looking for the factors of -8 that add to -2. So I have x squared equals 0, x minus 4 equals 0, and x plus 2 equals 0. So I have my first 0 is 0, and that occurs twice, multiplicity of 2. And then this one would be x equals 4, multiplicity of 1. And this one would be x equals -2, also a multiplicity of 1. So the even touches, and then the odd crosses, passes through that axis at that point. All right, number 8, you don't have to know this, but it is kind of fun to make these connections. So I'll just go through number 8. It won't be on your quiz, but let's just make these connections. So number 8 says a polynomial function has a 0 at -6 with a multiplicity of 2. And then another 0 at 2 with a multiplicity of 1. And based on that information, we're going to give the polynomial function. So how you would start this, your function f of x, if it's a 0 at -6, that means the factor was x plus 6. And since it's a multiplicity of 2, that means x plus 6 is squared. And then at 2, that would be an x minus 2 just to the first power there. Now if you wanted to, this is its factored form, but if you wanted to give it in standard form, what you could do is then you could say, well, this is x plus 6 times x plus 6 times x plus minus 2, and then you could FOIL this and then FOIL it again. So expand that by multiplication. And that's something that you would do in pre-calculus. So just giving you a little sneak peek there. And make that connection of going backwards. So given this information, you can actually find the function in standard form. So that's pretty cool. All right, so anyway, just to recap, we learned how to find the zeros and how to determine those zeros' multiplicity and what that all means in relation to the function's graph.